All right, let's draw the graph of this piecewise function. So I have two pieces to this piecewise function. The first two had three pieces. It's not required that your piecewise function have three pieces. You can have as many pieces as you like to a piecewise function. So my first piece is the graph y equals x squared. That is a parabola. I'm going to plot some points to help me draw that. Um, since it's x squared, you can always just remember to square everything. You go over 2, then you have to go up 4. If you go over 3, then you go up 9. And sketch in my curve. When I give you a graph to draw a parabola, a vague U shape is not sufficient. You want to make sure you've got a true parabola shape. So that's a pretty good parabola. Now notice that I want everything where x is less than 3. So that's this whole left side and all the way up to 3. So on this side it does keep going. So I put an arrow on that end. And this is a strict inequality, so that's an open circle at 3. And now for my other piece, this is y equals 1/2 x. So I'll draw in a line with this y-intercept of 0 and a slope of 1/2. And really, I know I don't need it over there, so I'm just going to draw my helper line in over here. And so I want this graph for x's between 4 and 8. So it's 2, 4, so I'll start here and go to 8. Notice that both of these are strict less thans, so I get open dots on both ends of that. And that's both pieces, so I can erase my helper line. If I wanted to, I could erase some of my helper dots, but that's fine to leave those. Now, there's a couple things I want to point out about this graph. Notice that there is a gap in the domain. We haven't had that before. All of our earlier ones, the domain of the piecewise function was negative infinity to infinity, even though it was broken up into separate pieces. This one only goes up to 3, then there's a gap, and then we have between 4 and 8, and then it does not keep going after that. So this has a sort of an interesting domain to it. And that's okay, piecewise functions can do that. So now go ahead, pause one last time, and draw the graph to number 4, and come back when you're ready to see the solution. All right, so let's do the solution to number 4. My first piece has the equation y equals -4, so that's going to be a horizontal line at -4. 2, 4. So I can sketch that in. And really, I can hold my ruler here and draw in. I need to make sure I stop at -2. Then I can put my arrowhead on that end. And on this end, I want this is a strict inequality, so I want an open circle. And then my next piece, -x plus 2, so that is a line with a y-intercept of 2 and a slope of -1. And I'm going to want that in between -2 and 1. So -2 to 1. These inequalities are both a less than or equal to, so they get solid dots. And then my last piece is the square root of x. So I'm going to plot some points again to help me graph that. So 0, 0, 1, 1. 4 is the next perfect square. So 4, 2 is 1. 9 is a perfect square. Notice that I'm ignoring bunches of points. I'm just picking the ones that have nice points on this graph. I'm picking perfect squares because they have nice square roots. So then I can lightly sketch in this graph. And then I can go over boldly the part that I want, which is everything greater than 1. And there we go. I automatically added that arrow because it does keep going. This is everything greater than 1. On this side, I would have an open circle, but again, it landed on top of a closed circle, so that point is defined there, and we leave it just as it is. So the only thing left to do is tidy up and erase my little helper markings. And there is the graph to our last piecewise function.